Okay, so 11.2 deals with simplifying radicals. And putting a radical in simplest form means the following things. It means that no perfect square factors other than 1 are in the radicand. We'll talk about what that means in a second. We can't have any fractions in the radicand. We don't like taking the square root of a fraction. And then lastly, that no radicals appear in the denominator of a fraction. So here we have this general rule for multiplying. If we have the square root of a times b, that is the exact same thing as the square root of a times the square root of b. So we use this rule to write fractions in simplest form. So take the square root of 60. The square root of 60 does not give you a nice clean number. It will be a decimal just under 8. How we simplify this now is we want to pull out all of the perfect square factors that go into 60. What that means is we have to ask, what perfect squares go into 60? So we're going perfect square hunting. This is the Duck Hunter game for the Nintendo Entertainment System. Came out before you were born. What we're going to do is we are going to hunt for perfect squares. So our perfect squares are 1, but we're fine with 1. Then 4, 9, 16, 25, 36, 49, 64, etc. So we're asking which of those numbers would divide 60 evenly? Well, the answer in this case would be 4. 60 divided by 4 gets us 15. So this is the square root of 4 times the square root of 15. Just going off of this rule, because 4 times 15 is 60. So now what we do is we can simplify the square root of 4. The square root of 4 is just 2. So we have 2 times the square root of 15. Now we can look at 15. Are there any perfect squares that go into 15? Does 4 go in? No. Does 9 go in? No. 16 is already bigger than 15, so 15 is as reduced as we can get. So we actually don't even need to put in this little dot. We can just write 2 root 15. This is the square root of 60 simplified. It doesn't look that much nicer, but it is by these rules. So we just went perfect square hunting. And that process works very, very well, and it's the fastest. But you need to be pretty comfortable with factors of numbers and knowing what your perfect squares are. So there is a longer way to do this, and I like to call it factor prison. So let's take 60. We've all made a factor tree before. We can just do it by 2's right away. 2 and 30. 2 times 30 give you 60. Okay, let's break down 30. 2 and 15. Okay, let's break down 15. 3 and 5. All of you have done this factor tree idea before. Okay, so now what we can do is we can just say the square root of 60 is the same as the square root of 2 times 2 times 3 times 5. Because our factors were 2, 2, 3, and 5 when we did our prime factorization. So the reason we call this factor prison is because you always need a partner to get out of prison, right? You need somebody to help you out. So the idea is here is if you have 2 and 2, they're going to make a partner so they get to get out of prison. So now you have 2 times the square root of 3 times 5 because the 2's got out together. 3 times 5 is just 15. 2 root 15. You get the same answer. It's a little silly, but it does work. This is a long process if you have a number with a lot of factors, but it does work. You need 2 people to get out of square root prison. The other way you can think of this is couples get to go out, single people stay at home. However you want to think of it, if you have a pair, they can come out, but remember they only come out as one single 2. Okay, let's move on. Let's do a couple more of these. Now we have the square root of 18x cubed. Well, let's just use this idea from before. Just break some things down. Square root of 18x cubed, well, that's just the square root of 18 times the square root of x cubed. We can do this in pieces, that's fine. Now we can either do factor prison or we can pull out perfect squares. Pulling out perfect squares is pretty easy in this case. 9 times 2 gets you 18. So we have the square root of 9 times the square root of 2. Looking at x cubed now, before we simplify over here, x cubed is just x times x times x. So what we can actually do is we can say this is the same as x squared times x. We're just taking two of these under one and putting the one underneath the other. And we'll see how this simplifies right now. The square root of 9 is just 3. So you have 3 times the square root of 2 times the square root of x squared. Remember, think factor prison. If you have x squared, that's like x times x. So 1 gets to come out. So we're left with just x. Square root of x we can't simplify anymore. Now we're just going to rewrite some things. We'll have 3 times x. Then we have the square root of 2 times the square root of x. We're just changing the order because multiplication is commutative. And then we can simplify in here. Instead of the square root of 2 times the square root of x, we can just say 3x times the square root of 2x. And now we are all simplified. If you'd like, go ahead and pause the video now. Try this one on your own. 12 times x to the 5th times y squared. Okay, here we go. Perfect square hunting. We'll break this down. 12, square root of 12 times the square root of x to the 5th times the square root of y squared. Ooh, that already looks pretty convenient. Square root of 12, that's the same as the square root of 4 times the square root of 3. 4 is a perfect square that goes into 12. X to the 5th, now we can break this up where we have square root of x squared times the square root of x squared times the square root of x, 2, 4, 5. Then we have the square root of y squared. I'm going to leave that be for now. We'll simplify it in a moment. Square root of 4 now is just 2. Then we have the square root of 3. The square root of x squared is just x. Square root of x squared is just x. Square root of x can't simplify. The square root of y squared is just y. So now we're just going to regroup some things. X times x is just x squared. So 2x squared y times the square root of 3x. We're just grouping these two things together and pulling these guys out front. And then we're grouping the square root of x and the square root of 3 together right here. So our final simplified answer is indeed 2x squared y times the square root of 3x. Okay, remember for number 2, we're told that we can't have any fractions in the radicand. So what this means is if you have the square root of a divided by b, you can break that up into the square root of a divided by the square root of b. So looking here, square root of 16 divided by y squared, well, that's the same as the square root of 16 over the square root of y squared. Okay, simplify more. Square root of 16 is just 4. Square root of y squared is just y. Done. So the idea is we don't want a square root of a fraction, just break it down. Okay, let's go the other way with this multiplication rule. We said that the square root of ab is equal to the square root of a times the square root of b, but we can also go the other way. Right now we have the square root of 2 times the square root of 8. Can't really simplify the square root of 2. We could square root of 8, but it might be easier just to combine these. Square root of a times the square root of b is the square root of a times b. So this is the same as the square root of 2 times 8. But we all know that's just 16. What's the square root of 16? 4. So you can go the other way as well. Let's go ahead and look at number 3 from the homework. This is the first question on the homework, square root of 20. Just straight up, you can either perfect square hunt, or you can do factor prison. I'll show both ways here. Go ahead and try it on your own if you want on your homework, and then you can check your work, see how you did. Okay, the first way I'm going to do this is showing how to pull out a perfect square. Well, perfect squares are going to 20. 1, 4, 4 goes into 20. So we have the square root of 4 times the square root of 4 times what gets you 20? Well, 5. 4 times 5 is 20. Square root of 4 is just 2. So we're left with just 2 root 5. Now showing how this works with factor prison. Break 20 down, 2, 10, 2, 5, can't do any more. Square root of 2 times 5, 2 and 2 have a partner, 2 root 5. You get the same answer, whichever strategy you want to use. We are skipping around here. I just want to show one example. We're not going to do that one. We're going to do 2 examples. We're going to do this one and then the one on the next page. What we need to do, number 3 on that list of things that we need to have happen for our expression to be simplified, was we can't have a square root in the denominator. So what we have to do is we need to rationalize this denominator. What that means is we need to multiply this whole thing, 3 divided by the square root of 5, by a form of 1 that gets rid of the square root of 5 on the bottom. And I'll show you what that means right here. What would we need to multiply square root of 5 by to get a perfect square number on the bottom? You might say 5 or the square root of 5, and that's absolutely right. Because the square root of 5 times the square root of 5 is going to be the square root of 25, which is just 5. So we're multiplying by a form of 1. So what that means is we're going to take something over itself. Like 2 divided by 2 is just 1. 6 divided by 6 is just 1. And the square root of 5 divided by the square root of 5 is just 1. So now what we have is on top we have in the numerator 3 root 5. In the denominator we have the square root of 25. But we know that the square root of 25 is just 5. So here is a more simplified answer than just 3 divided by the square root of 5. It doesn't really look like it, but we do not like to leave radicals in the denominator. So the quick and dirty trick is to just multiply by the denominator over itself if you're just dealing with a monomial. We're not going to get into these. So go ahead and try this one on your own. 4 divided by the square root of 13. Hopefully you remember from the last example, we're just going to multiply by the square root of 13 over the square root of 13. So on top we get 4 root 13. On bottom, 13 times 13 is 169. You really don't even need to put in this step, but I'm just showing 4 root 13 divided by 13 is our simplified version of 4 divided by the square root of 13. And that should wrap us up for 11.2. 11.2 can be very complicated if you don't understand what's going on, especially with either factor prison or pulling out perfect squares. I encourage you to look up YouTube videos on how to do this as well, just so you see a different perspective. They should be giving you similar strategies, but it's nice the more examples you see and the more examples you do, the better you will get at this.